Salutations, fellow chemists. Welcome to this video taking you through atomic notation. And in today's video, what I'm going to do is explain atomic notation very quickly. And then the second thing I'm going to do, take you through an easy, medium, and hard question. So let's get started. First thing is, you should know that X is representing any element. So that is any elements. That's the symbol for any elements here. And your A and your Z are representing two very important numbers we need to know about. The first one, A, is the atomic mass number, and your atomic mass number, how I remember this one, is it's the larger number, so mass, massive, the larger out of the two, and this tells us the number of protons and neutrons added together, protons plus neutrons. The second number here, the Z, is your atomic number, and this here is just the number of protons, so atomic number. And that will be number of protons Excellent. So what you need to know then is if you want to work out the number of neutrons, you need to take away your atomic number, the smaller one, from the larger one, which is your atomic mass. So that number of protons here cancel, and you're just left with neutrons. So I'm going to pop that on this side. So number of neutrons equals your atomic mass number, take away your atomic number. So that would be the A, take away the Z there, atomic number. Excellent. So that's nice and easy. What I'm going to do is swap colors now. So let's go to the red. And in red, I'm just going to give you a few pointers to help you in the next set of questions we're going to have a look at. So first thing over here is for atoms. So I'm going to use hashtag. Hashtag just means number. So in atoms, the number of protons equals the number of electrons. That's in atoms only. But in ions, so remember, how do we form ions? From atoms to ions, what we've done is we've lost or gained electrons. So in this case, the number of protons does not equal the number of electrons. And this is going to be very important in our example. So what I usually do is to work out the charge. That would equal the proton number, so hashtag number of protons, take away the number of electrons. And that will help you to work out the charge on these. So this is just a quick intro. What I'm going to do now is take you through some example questions. So we've got some easy examples on the board here very quickly. For the first one, you can see that we've got carbon and the atomic number is 6 and the atomic mass number, the massive one, the larger one, is 14. So the number of protons equals the atomic number. So that's easy, that's 6. The number of neutrons, you have to do the atomic mass number, take away the atomic number. So that would be 14, take away 6, which gives us 8. And for the number of electrons, because this is an atom with no charge here, we know that the number of protons equals the number of electrons. So that should be 6. And going through these very quickly, that would be 20. This here would be 40, take away 20, which gives you 20, and another 20, because the number of electrons equals the number of protons. Last example here, we have the smaller number, the atomic number is 11, the mass number is 23, so mass take away atomic number should give you the number of neutrons here, which is 12, and lastly, electrons equals the number of protons, because this is an atom, so that would be 11 over here as well. So that's the easy one. Let's move on to the medium questions. Let's have a look at our medium questions now. So here, to work out the number of protons, you should know that is the atomic number. So the smaller one is 20 here. And to work out the number of neutrons is exactly what we did before. Mass number, take away atomic number, will give you 20 here. The tricky part now is realizing we've got ions over here. So the charge 2 plus is going to be over here, let's say. And the number of protons we have is 20. And minus X as the number of electrons, because we don't know that. So if you rearrange and you move the X over here, it will be positive X. So you have X and then plus 2 or 2 plus, but we can put plus 2 equals X. So moving that over to that side, take away 2 from both sides, you should get 18 over here as your number of electrons. So we can do that for every single one of these. I'm going to use this to rub that one off there. And we can move on to the next example now. So here, number of protons is the atomic number, the smaller one, so 53. And number of neutrons will be the mass number, take away the atomic number. So in this case, that will be 131, take away 53, which gives you 78. And to work out the number of electrons here, we've got a -1 charge this time. So this would be -1 equals the number of protons, which is 53. Take away number of electrons we're trying to find out, which is x. Move that over to that side, that becomes positive x. That gets rid of that here. And add 1 to both sides, gets rid of this one, and adds on to this side. So our number of electrons now is 54. So that would be 54 on this side. Last example here. Now we have Fe2+, the charge is 2+, but let's work our way through the protons and neutrons first. So atomic number will be 26, the smaller one. So that's the number of protons. And then looking at 56, which is the mass number, take away our atomic number, gives you the number of neutrons. So that will be 30, very easy for that one. And then now we can work out the number of electrons based on the charge and the number of protons there. So charge is 2+ or +2. And then here, number of protons was 26 minus x. We're trying to find the number of electrons. So add x to both sides. That will bring the x over to here. We said that that can be +2. So take away 2 from both sides. We'll get rid of it from that side. We can take away 2 from here. And then that will give us 24 as our number of electrons there. So hopefully you're able to get all of these right here. And very quickly, you can also tell that we have extra protons here, 2 more protons than we do electrons here. So that means that the charge will be 2+, because the 24 will cancel out 24 protons to give you 0. But then we have 2 positive left over, so 2 protons which both have a charge of +1. And the same applies to the other ones as well. But let's look at the iodide ion here, where we've got 53 protons, which will cancel out 53 electrons, leaving 1 extra. Because electrons have a charge of -1, we end up with a -1 charge over here. So hopefully that's easy. Now let's have a look at the trickier ones. So these are our hard questions, the very last one. And to approach these questions, I've got a key over here. So a P+ just means number of protons, N0 just means number of neutrons, and E- just means number of electrons. So the first question says an atom with 2 fewer protons and 2 more neutrons than 14(7) nitrogen. So what we're looking at here, protons wise, we have fewer protons. So even when we look at where we start, it has to be 7 based on the atomic number here. And the number of neutrons, 14 take away 7 is 7. And because this is an atom here, we have the same number of protons as we do electrons. So if we have fewer protons by 2, -2 over here takes us to 5. The number of neutrons, it says we have 2 more neutrons, so we add 2. That takes us over here to 9. And then if you have a look over here, because it says it's an atom, you know that the number of protons and electrons in an atom have to be the same. So here we also have 5 electrons to keep the number exactly the same here. So if you look at your periodic table, you should know the unique identifier for an element is the proton number. So they are arranged in increasing order of atomic number. So here 5 would give us boron. And you need to work out the mass number for this here. So 9 plus 5 is 14. And because we have 5 protons, the atomic number is 5. So the correct answer here is boron, 14 with 5 protons there. Okay, moving on to the next one here. An ion with 1 more proton and 4 neutrons than an atom of 2311 sodium, but with 1 fewer electrons. So we have 1 more proton and 4 more neutrons there. So proton starting off here is 11. Neutron number 23 minus 11 is 12. And this is an atom, so these two will be the same. Now we know that we have added a proton, so +1 here. So we have 12. Here, number of neutrons, we've added 4. So we've gone from 12 to the 16 now. And here we have 1 fewer electron than what we started off with. So here, -1 will be 10 over like so. So now what you need to do is go and have a look at your periodic table, and you'll see that the elements that has the atomic number of 12 is magnesium. So here we have magnesium. And the next job is working out the mass number. The mass number will be the number of protons plus the number of neutrons. So 12 plus 16, 28. And then lastly, you know that this is going to be 12 over here. But that's not it, because we know we have an ion here. So we need to think about the charge. Remember, the charge equals the number of protons, take away the number of electrons. We've got 12 protons, take away 10, that gives you 2. And we know protons are positively charged. So having 2 extra protons gives us a charge of 2 plus. So that is it for these questions here. Hopefully you're able to understand atomic notation a lot better through this video. Make sure you like, make sure you subscribe, and I will see you very soon.